Hello everyone. Today we will discuss about graph in data structure section. A graph is an abstract data type that means the implementation of the undirected or directed graph in mathematical notation. The main difference between tree and graph is in the tree section we don't have a cycle, but in graph section you can see in this diagram that we are having a cycle. So the tree will be a graph if there is any cycle. A graph representation in memory can be adjacency matrix or adjacency listing. By matrix section we can do like this one. That is why it is known as adjacency matrix, which is also a two-dimensional matrix which is our size in V into V section. The adjacent matrix will be looks like this. Here the size is 4 by 4. That means here the index is started from 0. That's why the index goes up to the 4. That means the total size is 5 into 5 matrix, and there are all the values of indexing in the adjacency matrix representation of graph. Now we are in the adjacency listing. In this section we need just to make a list. Here we have from 0 to 4 where we have 5 values and we have listed them like this one. That is how the adjacency list is represented in the above graph. Here we can have an array of one dimension. Linked representation of a graph. Here we are connecting from A to C, D and B, and then from B we are connecting to C, and so on. By these nodes we can see that here the main nodes are A to E. Here we have 5 nodes, and adjacency list we can see by that in A we are connected with B, C and D. That is why in adjacency of A we have B, C and D. In B section it is connected with only the C, that is here, and the C is not connected with anyone, so it's null, and D is again connected with C and E, and E is lastly connected with the C section. That is why the table is okay. That is how the adjacency list of C works in the graph section. Now this is the linked list view of this table. You can easily understand that by here from the starting position we firstly go to the A section, and in A section we need to communicate with B, C and D. That is why we have go from A to the B section. Then by this line we are going to the C section by this point, and where by this point we are going to the D section from A. The B is connected to the C, that is why we are going from B to this section to connect with the C. That is how the table works on this diagram. Now the warshall's algorithm is quite important for your theoretical point of view. You can have a snap of this one and go through. Now the important things are graph traversal. In this section we have two traversing section. One is BFS, which is breadth first search, and DFS, which is depth first search. In this breadth first search section, the breadth first search is an algorithm for traversing or searching trees or graphs in data structure to start at the tree root or some arbitrary nodes of the graph, and sometimes referred as a search key 1, and express the neighborhood nodes first, then before moving to the next neighborhood. That is why the breadth first search go. That means it will start from the root A and moving to its neighbor and then moving to another one. Now the depth first search. In the section of depth first search of algorithm of traversing searching the tree of graph in structure one starting node selected an arbitrary node as the root section in cause of graph that explore as a far possible along the each branch before backtracking. Here we have the tree edges and the blue edges and the cross edges, and where we have the forward edges. This depth first search will mainly focus on removing the backtracking section. It will go from here to there by this will works on to have the minimum size of backtracking. Some advantages and disadvantages are given here of graph section. You can have a snap of this one. That's for today. Thank you.